One of the most useful features of op-amp circuits, such as those that you've been learning so far this week, is that they can be used as fundamental building blocks to construct fairly complex systems. It's very easy to connect the output of one amplifier to the input of another. This can be done provided that you always remember two things. First of all, you want to make sure you don't break the fundamental principles we talked about earlier in this module. And second, you want to ensure that the input impedance of one op-amp is sufficiently large so that it doesn't load the output of the circuit that you're connecting it to, such as shown here. The other thing you want to make sure is that the output impedance of the op-amp is sufficiently low so that the entire voltage that the op-amp is producing, or the circuit is producing, will indeed get delivered to the circuit at the output of that. Again, these two things, considering the input impedance of one op-amp circuit and the output impedance of another, are relatively simple given the features of an op-amp and especially how they behave with negative feedback. In your homework now, your job is to take the circuits that you've built to construct a fairly complex mathematical function. This can be done using the summing amplifier, the differential amplifier, the inverting, the non-inverting amplifiers, or the buffer. You may also need to consider how to take a signal and level shift it, as we talked about in the last card. So now I challenge you to go ahead and take what you've learned and put it together into a more complex system. Good luck.